Hello, this presentation is directed at two questions. These are, does anyone really need high dynamic range photography? If so, what is the easiest way to perform it? Let me show you two pictures to address the first question. I took this picture out of my kitchen window just before the sun came up. This was the establishing shot for a series of pictures that would be used to create a final HDR picture. I have taken many pictures like this in the past that have always yielded great disappointment. The sky is blown out, too much white, and other details are too dark. But by combining this picture with four others that were also taken at this time, and using the appropriate software, I get this HDR picture. Now I ask you if this picture isn't a vast improvement. It is a picture of what my eyes actually saw looking out of my kitchen window. My eyes can see a much higher dynamic range than any single photograph can yield. This picture is about as close to photographing the actual world as can be expected, and it looks natural. The camera that I'm using for this presentation is a Pentax K-3, and the software is PhotoMatix Pro version 5. My Pentax camera can be set up as shown in this table. The Pentax has two methods for making HDR pictures. The first and most general is called bracketing. This method has been around for a while and is present on most modern digital cameras except maybe the point and shoot variety. The second method is called built-in and can be found on the Pentax K-3 as well as others. This method uses 3 frames taken at variable shutter speeds and then merged within the camera. This produces a single raw file of about 90 megabytes that is saved by the camera. The separate settings that are on the screen are what I use for each type of HDR. The first picture that I showed you was numbered 1436 and was the establishing shot. The next 4 were 1437, 1438, 1439, and 1440. The camera had been set to take bracketing shots. This table shows the data for several HDR pictures. The first set of numbers are for the pictures under consideration. The first pictures were taken by what I call the variable ISO method. All of these pictures were made handheld without a tripod. The first law for HDR photography is that each picture for an HDR set must be taken at the same f-stop. There is a very simple reason for this, and it has to do with what is called depth of field. Attempting to align and merge all 5 pictures without consistent depth of field would be nearly impossible. Notice that for each HDR set there is a constant f-stop. In order to take variable ISO pictures, the camera must be set as this picture illustrates. This will yield a constant f-stop, constant shutter speed, and variable ISO value. The variable shutter method requires that the camera be set like this. This will yield a constant f-stop, constant ISO, and variable shutter speed value for each picture. Handheld capture requires that you know beforehand the slowest shutter speed that will be used. It should be equal to or faster than 1/30th of a second when you press the 1 push bracketing shutter release. The 1 push option can be left on permanently since it is only used for bracketing. The question is, what will be the value of that lowest shutter speed or lowest ISO value? Observe that for either the variable shutter or variable ISO method, there is a column labeled step. The values in this column are the keys to how HDR works. The first shot of the bracketing series is the establishing shot, and always has a step value of 0. The other values are either greater than or less than the establishing shot. Minus means division and plus means multiplication. The crucial point is, what are the true values of the divisors or multipliers? The step facts are in fact exponents for the number 2. We can estimate these values by knowing the step value for the extreme photographs. Suppose, for example, that the largest step value is 3. Then 2 to the third power is 8, and this is the number we divide by to obtain the slowest shutter speed or ISO value. If the largest step value is 4, then the divisor is 16. It becomes virtually useless to exceed the step value of 4 because these extreme shots become either too dark or too white to have any useful value. They essentially fade to black or blow out to white. Knowing these values, in fact, allows us to preset the camera for the establishing shot. This will set our 0 point. When I set up the camera to take an HDR, I select my method, variable ISO or variable shutter. I always assume that my slowest shutter speed will be 1/30th of a second or faster. From experience, I know that I can handhold the camera at this shutter speed and get good results. You may want to use another slowest shutter speed. When I took the 1436 to 1440 series, it was just before sunrise, and I needed to set my establishing photo for those conditions. I also wanted to use variable ISO method. I needed to set my camera to the shutter aperture preferred mode first, and the camera to 5-step bracketing mode with 3 as the highest step value. 2 to the third power is 8, and this is our maximum factor. Since I want variable ISO, the shutter speed and aperture will be constant. I chose the shutter speed to be 1/30th of a second since I already knew I could take satisfactory HDR pictures with this constant speed. The minimum ISO value for the Pentax is 100, so I chose the 0 state establishing shot ISO to be 1100 for 2 reasons. The first reason is that it would make a correct exposure with a camera f-stop of 3.5 and a shutter speed of 1/30th of a second, which I found by trial and error using the existing light. The second reason is that the smallest and largest values of the ISO are calculated to be 1100 divided by 8 and 1100 multiplied by 8. These are 138 and 8,800 respectively. The closest values that the camera could match were ISO values of 200 and 9,000 respectively. This is close enough. I autofocused the camera and pressed the shutter release, and because the one-touch feature was set, I got 5 exposures in less than about 2/3 of a second. The Pentax will take about 8 frames per second. For the bracketing series 1441 through 1445, the maximum step value was 4, and I again chose the variable ISO method. 2 to the power of 4 is 16. I set the establishing shot ISO to 2200 because 2200 divided by 16 is 138, and 2200 times 16 is 35,200. The camera assigned ISO 200 to the -4 step and 36,000 to the +4 step. I set the establishing shot shutter at 1/45th of a second and the f-stop to f4. In simple English, I never have to do these calculations again for variable ISO HDR. If my maximum step value is 3, then set the establishing shot ISO to 1100. If the maximum step value is 4, then set the establishing shot ISO to 2200. There is symmetry in this. If you cannot get a shutter speed greater than or equal to 1/30th of a second at any f-stop to work for the establishing shot, then get a tripod. Let us think a little bit more about the available light. For the shots taken at dawn, I barely had enough light to capture my subject. This is one of the main reasons I chose variable ISO. I knew that I had to work at a constant shutter speed and f-stop. I knew that my limiting handheld shutter speed had to be at least 1/30th of a second, and I also knew that the limiting f-stop for me was 2.8. This is why variable ISO works so well in low light. It will also work at high noon. This table shows that for an establishing shutter speed of 1/750th of a second, any f-stop that produces a well-exposed step 0 shot will work until you run out of f-stop. If you run out of f-stops, then change the shutter speed. Any combination that works is okay until you get below a shutter speed of 1/30th for handheld HDR. Note especially the min column. Variable shutter speed is more problematic. Another bracketing example is the case of variable shutter speed combined with constant ISO and constant f-stop. Note that you must set the camera to aperture preferred mode for the variable shutter condition. Here again we are interested in the slowest shutter speed in order to hand hold during the rest of the exposure. This example is covered in the 1490 through 1494 bracketing series. These pictures were shot with much more available light. The establishing shot looked like this. The HDR version was like this. In our example, the largest step value was 3. Therefore, our multiplication division factor is 8. I deliberately picked the lowest shutter speed to be 1/60th of a second. The establishment 0 step frame is then 60 multiplied by 8, which equals 480. Notice that I just used the denominators of the shutter speeds. Set the 0 frame shutter speed to 1/500th of a second. It is the establishing step 0 shot that sets the stage. I then found a constant ISO and f-stop that satisfied the ambient lighting conditions at a starting shutter speed of 1/500th of a second. For this case, they were ISO 800 and an f-stop of 9.5. It is crucial to remember to set the camera to TAV or AV depending on your preference for ISO or shutter variability. The camera should always be set to press the 1-push shutter and obtain the 5 bracketing exposures. For comparison purposes, I also shot the variable ISO series 1485 through 1489 and the variable shutter series 1490 through 1494. This is essentially the establishing shot for both series. Here's the HDR version for the variable ISO method. And here is the HDR version for the variable shutter method. These two HDR results are virtually identical. This proves that you will get the same outcome no matter which method you choose. It should not be surprising since the same step values were used. The Pentax K-3 also offers another method for taking HDR pictures. This is the built-in method. The built-in method is always variable shutter with 3 exposures. The step selections are ±1 or ±2 or ±3. In my opinion, the best condition for the built-in method is the ±2 condition. The first condition is not broad enough, and the third is too broad without a fill picture between the establishing shot and the ±3 shots. Here are some HDR pictures to illustrate the differences between the ±2 and the ±3 conditions. The ±2 picture looks like this. This is after processing. The ±3 picture looks like this. Now, to me, it looks duller than the first picture. I prefer the ±2s for the built-in method in the camera. This concludes how to take HDR photographs. This part of the presentation is about processing multiple pictures into an HDR picture. First, I will process 5 exposure bracketing shots to a final HDR picture. I will cut out the slow parts to save time. I have opened PhotoMatix Pro, and now I load the shots 1441 through 1445. I always use the raw files for my HDR work in order to obtain the maximum quality. Here I've got them loaded. Now we'll click OK. And here's the screen that's always presented when you're using bracketing pictures. It offers many opportunities here, but I always use basically the same ones. Handheld, show options to remove ghost, which I'll cover in a few more minutes here. And then these other options about reducing noises and reducing chromatic aberrations. I'm going to click here and start this process. I'll pause here just to shorten the time scale here. I return now after doing a lot of work with the time-consuming stuff. And here's the major option that PhotoMatix offers, and it's called deghosting. Now, deghosting is used for removing motion in your pictures, like if you've got a car driving by and maybe you want to remove the car, these kind of things. And in general, you can test whether the deghosting process is even necessary by taking this slider right here and sliding it over anywhere you want and then letting go of the... And if you notice, the data image didn't change hardly at all. If I slide it back to 0, let go, a little fuzziness occurred around the windows that were removed, but I don't really care about that. I'm going to leave that fuzziness in, and I'm just going to treat this with no deghosting. So, but if there were things in there that had bothered me, I could have removed them. And the reason that you have to do it at this stage is that the images have not been merged yet. So what we were doing was trying to clean up some images that were going to be merged into the final picture. But right now we're not going to operate on those images at all. We're just going to go ahead and merge them. Again, I'm going to shorten the process a bit. Now the processing has been merged, and we're now ready to tone map the HDR image. These images that you get just for HDR look very, very bad, but it's here that the processing is really going to turn into something miraculous. So I'm going to click this tone map button here. And here's what my default setting has been exposure fusion with a option of using interior 2. You can see this over here where the cursor is going around and this square is drawn around this option. So this is the interior 2 fused image option, which I use most of the time. And I always like this, so I'm going to apply this. Now I'm going to apply that option to this HDR picture. You can see that it is fusing the images. I'm deliberately letting this run just to show you how things can get pretty time consuming. Probably should have paused it. Now here's the final image. And I can save this final image in 2 different formats. If I click Save Final Image, I can save it as a JPEG format or a TIFF format, either 2 forms of TIFF format, TIFF 8-bit, TIFF 16-bit. Now I'm not going to save it at all since I already have it saved, but this illustrates how PhotoMatix can take 5 images and build them into one and produce a visual treat. I have to emphasize that this is what my eyes saw again. Now this part of the presentation is about processing a Pentax built-in RAW file. When you use the built-in method with the Pentax, it will take 3 photographs and merge them into one file. Here's an example right here. These properties are that it's 83.2 megabytes big for one file. Now there's no way to put this directly into PhotoMatix Pro, but there is a way to get it in there through the back door. And this is by right-clicking on this and say Open with PhotoMatix Pro. So I'm going to open this very large raw file with PhotoMatix Pro. Notice I do not get the same kind of options that I got before when I had 5 images that were going to be merged. All I'm going to do is take this one giant image and PhotoMatix Pro is going to use it. So I'll click OK. Now I may pause here for a bit just to save time. Now PhotoMatix Pro has processed that 3-in-1 image business that Pentax produces, and by default has produced my exposure fusion picture, which I don't particularly care for in this case. Other options here are kind of interesting to investigate just because of this. Here's one called Enhance 2. Now, this is my standard exposure fusion method image, but I'm going to try just a tone map method right here, which produces an image which I like a whole lot better. Now, instead of always using my exposure fusion, I'm going to use one of these tone map options. And I can apply the option now. I think I'll pause this for a second. Now here is the tone mapped image, which I think is quite good. And if I want to save it, it's the same old deal. Save final image. And go over here and save the type. I usually always save JPEGs, but you've got 3 options here. I'm not going to save it because I've already done it. And one of the things I should explain again is that with the in-camera Pentax options, deghosting is not allowed. So if you're going to have a problem with deghosting, then probably don't want to use the automatic system that's built into the Pentax. Well, this ends the presentation. I hope it was useful.